Hi, this is my last of the short review problems that I did, basically some of the problems that I gave you in class. And now we're on to 30, 60, 90s. Those get a little bit trickier, so I'm going to go ahead and draw the definition of this one. Choop. Maybe I will, maybe I won't. Why isn't it not working? There we go. I better erase that. And boom. So I have a 30, 60, 90. There's my right angle. Let's put 30 on top, 60 on the bottom. Usually you just have one angle indicated, like over here we just have 60. We're going to have a radical 3, and 2a. This is the short leg, this is a long leg, short leg, long leg, hypotenuse. Alright? So we're going to do it just like we did before. We're going to find out what we're given and plug it in to what we know. Well, over here it's 30. Remember, we can rotate these things. Opposite to 30 is my short leg. This is a. So a is equal to 8. And we'd put that 8 anywhere we see an a. I put it right here, and I put it right here. So there goes an 8, and there goes an 8. So this leg over here is 8 radical 3, and this is 16. Okay, let's take a look at the next example. So again, let's grab the definition right here and plug in what we know. A radical 3 and 2a, and this is 30. This is 60. Okay, so let's take a look at what we have. What we do is we have to identify where this 20 belongs on our definition. It's opposite to 60 degrees. Opposite. So we're going to plug this in wherever our 60 is. Here's our 60 right here. We're going to have a radical 3 is equal to 20. And we solve that equation using the skills that we developed in part 1 and part 2. So here we go. I'm going to divide by radical 3 on both sides. And you're going to start seeing a shortcut here real soon. I hope you do anyway. And that's just going to be a is equal to 20 over radical 3. Multiply by 1 again. Boink. Whatever's in the denominator. Those are both radical 3's. This pen doesn't like 3's, and neither do I. So that's nothing more than 20 radical 3 over 3. That is a 3. That is my a. That's what goes right here, opposite my 30. So this is nothing more than 20 radical 3 over 3. This is 2 times that. I put in this 20 radical 3 over 3, 20 radical 3 over 3 into a right here, because that's 2 times a. So this y is 40 radical 3 over 3. I believe I have one more example for you. And this is our typical equilateral triangle. All 4 sides are equal. That's x, this is x, this whole thing is x. That means this is going to be half of x, or 0.5x, however you want to think of it. So what we're going to do is, again, let's go to our definition. Fill it in. So what we have here is our right angle. We have 30, 60. All right, so this is a radical 3, and 2a. And this is what we're looking at, this triangle right here. This guy. So that a radical 3 belongs to the 30. So we set up the equation, a radical 3 is equal to 30. I'm going to have 30 radical 3 over 3, which is 10 radical 3. How did I do that in my head? You figure that out, all right? So, and it's not because I'm a math teacher. It's because I'm seeing the pattern. So we're going to divide by radical 3 on both sides. Radical 3 over radical 3. And we have a is equal to 30 radical 3 over 3. I guess I should not use 3's in my examples. I can't help it on this one, though, can I? Oh, well, such is life. And I skipped a step because all I did was I just multiplied by 1. Let me show you, just in case you get a little upset here. So I have 30 over radical 3, right? I'm going to multiply by 1. Radical 3 over radical 3. And that is equal to 30 radical 3 over 3. And that is equal to 30 divided by 3 is 10. 10 radical 3. That's what my a equals to. This right here, this side right here is 10 radical 3. I'm sorry. 10 radical 3. Uh-oh, my pen's acting up again. No! No! Please don't say it's so. Okay, this is just 10 radical. Yep, there she blows. So she's a goner. Okay, so you get the idea. The answer is 10 radical 3, and it's almost time for me to invest in a new writing pad. Okay, bye.